Welcome to this edition of Train the Trainer with Jim Vaughn, CUSP. He is the senior consultant at the Institute for Safety and Powerline Construction. We're going to be focusing on training users on aerial lifts. His article out of IP Magazine. Welcome, Jim, to the podcast.
Oh, thank you. Thank you for making this available to us, too.
Oh, you're welcome. You know, this is your article in Incident Prevention Magazine. You have your section, Train the Trainer, which is on the website, as well as, every issue of IP. What are the most common mistakes that operators of aerial bucket trucks make?
It's the mistakes, which was the driver. And of course, we have a different topic every time, and usually that topic is inspired by something that we've come across. And one of the things that I do in my normal job is I consult with companies, including legal actions, and often has to do with equipment. And when we research the equipment, and especially if it's been an incident or an accident, and we're looking for the issues that resulted in the incident, or what we call the mechanism of injury, and we find out that there hasn't been a lot of attention paid to the development of good training and good practices with equipment. Now, we have to give a lot of credit to linemen, and I am one and was one, and we know that in the evolution of our skills, we work with equipment all the time. We train with equipment. We demonstrate equipment. We become very, very, very efficient with it. But just like a lot of different issues in the industry, we don't always understand the underlying technology or what it takes to put a piece of equipment together. And if we're not paying attention to the manufacturer's instructions and materials that they're providing for us, then we're not doing a very good job of taking good care of our equipment. So we have several different things that we see, and one of them is, and I'll talk with this in a minute because this surprised a lot of people, and it has to do with cranes. But the other is simply the operation of the equipment itself and the limitations of the equipment. The biggest thing that we see is turntable failures that are the result of the manner of operation. Sometimes it's because we put side strain. So the turntable is a gear. It's a big gear that has a small gear that rotates it. It's not designed to lift 10,000 pounds. It's designed to create the rotation force to rotate the boom. The weight and stress resistance of the boom is designed for straight up and down, from the ground up to the end of the boom. That's where all the structural integrity is to be able to lift that kind of weight. Well, if I put a side strain on the boom by taking the cable down from the boom, stretching it out, grabbing a pole, and then winching up and pulling it sideways, if I do that, then I'm putting a side strain on the turntable. And then eventually the turntable fails. And when we go out with utilities and we consult, one of the things that we do is we ask them to give us access to 4 or 5 of their digger derrick trucks and their bucket trucks. And then what we do is we take the boom up, we swing it around at a right angle, and we bring the tip of the boom down. And we walk out to the tip of the boom and we grab the boom, and then we push it back and forth. Now, the amount of movement on the end of the boom is determined by what's called the backlash in the gears. So here's our big turning gear, and here's our small gear that makes the gear operate. They're supposed to be fairly tight together. That space is called the backlash. Well, when we rotate a boom around and we come to a sudden stop, and now the weight of the boom slams up against that pinion gear down at the bottom of the boom, it starts to wear or hammer or dent all of those gears so that the backlash opens up. At a certain point, that backlash weakens the gear and the gear is going to fail. And we constantly put stress against that because we don't control the movement of the boom. So we have what's called tension controls. If I push forward on the gear or twist or however the operator's control is, the easier I push it, the slower the boom starts. The easier I back off, the slower the boom slows down. So if we start easy and stop easy, we limit the amount of pressure that we put against that gear, which again limits the amount of wear and tear. So I can go and look at a boom that's only 2 years old, and I'm not a mechanic and I don't have to do the inspections, but I learned this from the manufacturers that if I stand at the end of the boom and grab it, and if I can move it 2 feet like that, I can tell how their operators operate. I can tell how that company is not aware of what it is that they're doing out there, that they're damaging those pieces of equipment. And then you go over another 15 degrees and do it, and now you have very little movement because that's not where the boom works. So once we take a crew and we show them this, they go, ooh, because what happens often, more often than you think, is somebody will swing a boom around, whether it's a bucket truck or a digger derrick truck, and they want to bring it to a stop. And then they hear a big ping, and it doesn't stop. It keeps on going because the gear, the turning gear, the rotation gear has sheared off. And now there's no way to stop the boom because there's no brake. It's a hydraulic gearing system that makes it go and makes it stop. So you can go to these companies, and it's the same thing that we do. It's another little trick that we use in an audit. When we go to the garage, we look for all the stuff they got stacked up that they've been fixing. And you'll go to some locations, and it seems to be more with contractors more than anything else, and you'll find a whole bunch of rotation gears sitting on a pallet someplace. They say, gee, how many of these do you change out? Oh, we change a lot of those out. They don't realize that they're changing them out because they're being abused because they haven't trained their operators on the limits or the kind of damage that they're doing to that piece of equipment. But there are a number of things that we do wrong, but that's probably one of the more common ones. And then the other one is using material handling jibs to move energized conductor. I don't know if I even want to get into that.
Okay. Interesting. Yeah, that's if you got a pallet of parts to replace, I mean, clearly something's going wrong. You think you'd ask the question, why are we going through so many of these? But
yeah, and I hope that everybody caught on the things that we learned to look for that tell us something else about what's going on in that company. So being able to take a boom, and if you take 5 bucket trucks and you swing the booms over and you grab them, they're all 2 years old and they've all got 2 feet of movement at the end, then you've got a lot of people that haven't been trained about how to operate that bucket without wearing it out before it's time.
Now, is that from that leverage of that small gear on that large gear, widening the spacing between the teeth on that gear, or is it the shaft movement?
No, it's the teeth. Yeah, it's the teeth. It's that backlash. It's supposed to be tight. The backlash is a description of the amount of movement that's in the gears. And as the gears start to wear down, that gap becomes wider. So that means there's more backlash. So you've got 30 feet of boom stretched out from the turntable. A quarter inch of movement at the turntable equals out to, I don't know how much, a couple of feet of movement out there at the other end of the boom. And so, of course, even that makes your accuracy and the control of the boom a lot more problematic. But the biggest thing is that when you're wearing that tooth down, that you're also wearing down the strength of that tooth, and eventually it's going to break.
Yeah. Okay. So why are jibs not considered insulating for the purpose of contacting energized lines?
Yeah, this is something that is really easy to see. Anybody can get the what's we call it, the A92 standard, which is the consensus standard to which bucket trucks are built. And this is also where you find all the categories of insulating qualities, what gets insulated, what's not, what you can use it for, what you can't use it for. And the other part is the way that we test equipment that we use for the primary protection of the worker. So the primary protection of the lineman is the work method that's used to that keeps the lineman isolated from electrical contact. So we can either do that by insulation or isolation. And so MAD would be isolation. If I stay 3 feet away, I can't come in contact, can't get hurt. But if I have to put tools in contact with energized conductor, then I have to use some form of insulating material to provide that insulation between the worker and the environment. So primary insulation is characterized by components that can be tested periodically to ensure their integrity. With hot sticks, we constantly test hot sticks to make sure that that hot stick is still rated for 75,000 volts a foot. We do the same thing with rubber gloves. We test category 2 rubber gloves at 20,000 volts for 18,000 volts use, I think that is the numbers. If I get that wrong, forgive me. But we periodically test all of these primary means of insulation. We do the same thing with booms. Now, the bucket itself is not considered, we make them out of fiberglass, but it is not insulating. It's not tested for that. It's not designed for that. It's not designed for that by the standard. But the same thing applies to the material handling boom. The material handling boom doesn't get periodically tested. It was never designed to be insulating. It was built out of fiberglass in order to do 2 things. One is to keep conductive materials out of the work environment, and the other is because of weight and strength. Well, all of the manufacturers agree with the A92 standard, and all of them explain in their manuals that these material handling booms, even though they're made of fiberglass, and just because they're orange doesn't mean they're insulating, are not designed to be put into contact with the energized conductor. Doing so energizes the end of the boom, where the bucket is, where the controls are, where the workers are. They've energized that whole thing because that boom, that material handling boom, is not considered insulated for the work. Now, there are companies that do test their equipment, and they do testing on the boom itself, and they say that that's good enough. But what the standards require and the manufacturers require is a tool that attaches to the end of the material handling boom to create a isolation or an insulated stick or an insulated section that does come in, or is designed to come into contact with the conductor. So the problem is that a lot of people don't know this, and they're creating this issue by clipping wire into that wire holding clip on the end of that boom. And it's there because the boom was intended on being used to pick up de-energized conductors and to be used as a mechanism to move those conductors. But everybody simply needs to read the manual that comes with the boom about the material handling jib and what its limitations are, and then get the appropriate adapters in order to make that. Now, the other issue with putting energized conductor in the wire holding clip at the end of the boom is that that conductor is now within the MAD of the worker. And if you remember, the rules for MAD are that everything that I am not in contact with in order to perform a task has to be covered up. We put conductors in the end of a material handling jib, and we stick it up in the air, and it's 1.5 feet or 2 feet above my head, and we don't cover it up. And we go about work, changing the pole top or whatever it is that we're doing, and we're working within the MAD of that conductor that we are not working on. So there's a requirement there that we're supposed to be covering that conductor or insulating that conductor from the worker while we're not working on it. So there's a couple of other work methods that would be required if we were going to do that. I don't like the idea of putting a conductor on the jib because having been there, I don't like the idea of having that energized conductor on the end of my aerial platform. If something goes wrong, I can't get away because you got a conductor hanging on to it. I would much rather use one of the old methods that we've always used about handling conductor, using sticks or using a digger derrick with a link stick, or picking it up that way instead of picking it up with the boom. But that's just been the evolution of, we call them the material handling boom, is because the industry wanted to create a work platform that I could put two guys in and put a crane on it, and I could do everything with that truck and not have to have any other equipment out in the air. And I think that's led us to make some bad decisions.
Yeah, no, that makes sense. I mean, due to, sounds like efficiency on the job site, that maybe had some short-sighted thoughts on how to operate it, because that can cause fires in the bucket and cause some major problems. And again, you're in the air, so how are you getting out of there? How are you getting away from that?
Yeah, and by the way, we've done a couple of cases on fires in the bucket, and those fires in the bucket were caused because the insulating jib was on conductor, and then something happened in the mechanism of the bucket itself that created a problem. And in two of the several cases that I've done, they thought that they had isolation or insulation on one conductor, and then allowed another conductor to come in contact with the boom, or a neutral to come in contact with the boom. One was a down guy that came in contact with the boom, and it created an electrical pathway across the boom that resulted in failure of a hydraulic system that pumped flammable oil into an electrical arc and started a contact. And they couldn't get away because they had a conductor in the boom. So that's an issue that we addressed in the article to get everybody's attention, is that there are people who think that a fiberglass bucket is insulating. And what I told them is that if you've got a conductor laying on the lip of your bucket and you're using that to move it from one location to the other, you're essentially breaking the law, but you're setting yourself up for a failure, because the electrical design was not to permit that. We shouldn't be doing it, and it happens a lot.
Wow. What are some requirements for training operators of aerial bucket trucks?
Well, the first thing is the manufacturer's operating manual. Everything's right there, and it doesn't matter who your manufacturer is. And we only have two or three of them in the industry that are well known, well recognized. Every one of their manuals say the exact same thing, because they're all based on the A92 standard, which is the standard for insulated aerial devices. So that's the very first thing that you use as your curriculum for training of your employees. But I don't have a percentage, but I probably wouldn't be wrong to say that more than 70 or 80% of the linemen that we have that are running bucket trucks have never opened the operator's manual on that truck. I can say that because of I've done more than 700 incident investigations in the last 30 years, and not one of them that involved the operation of a dig derrick of a boom or a boom had the operator read the operator's manual. So, we're not doing a survey, but we're pretty close. And anybody that's listening to what we're saying is probably thinking, well, yeah, I guess I never have either. It's rare that happens. It happens after an incident occurs, when people pull out the book and start looking at it because they got challenged to do so. But when it comes to an investigation, or when it comes to the defense of a manufacturer, we as the legal or the consultants in a case, those are what we call the conditions of care. That's the first thing that we go to, is we look and see what that material says. And that material is the basis for the training of the operators that we have. So when we help somebody to develop operator training, the very first thing that we do is get copies of all the equipment that they have, to the operating manuals, to make sure that it's right. And then we use the consensus standards, and then we use the OSHA standards, which are not very specific. They have expectations of what the training is supposed to accomplish, but they don't tell you what the content should be. The content comes from the manufacturer's operating manual.
Yeah, I think in my own personal life, just nuanced things putting together, or things that you buy, right? I don't necessarily read the manual until I guess you have a problem. And that's kind of what it sounded like from an aerial bucket perspective. But it probably should be required, right? If you're using this thing day in and day out, and your balance of your life is in its hands, you should probably know how that piece of machinery operates.
And I think one of the things that concerns me, where the majority of my career has been in contracting, is that it doesn't matter what contractor that you work for, or whether you're union or whether you're not. Everybody has a different mindset about operating equipment. I may get in a bucket truck that looks really good and is brand new, but the reality is I have no idea who was operating that last time and how they were operating it, or what kind of abuse that they were putting on that piece of equipment.
Yeah.
And so one of the things that doesn't happen that should happen also is inspections of the equipment. A lineman assumes when he comes to work for a company and he's got a new truck and it looks good, that it's going to be good. And sometimes the only inspection that happens is sometimes they fly the booms. And I hate to be, sound like I'm accusing everybody of of being bad about this, because I do go and do audits with companies where they do fly the booms and they do inspections on them. But we've had enough failures in equipment over the years, and I've seen enough of them over the decades that I've been investigating these incidents, that the failure point in the mechanism would have been detectable in an inspection. It's just that nobody ever looked at it. Had a bucket come off of a boom, and in the inspection, post-incident, and then inspecting other booms associated from the same manufacturer, we found out that of the 6 bolts that were holding the boom on, 4 of them had been damaged. And it was detectable. But no, all you had to do was grab the bucket and shake it and see that it was loose. But nobody ever did that. And then it broke. And when it broke, it came close to being disaster for the 2 linemen in the bucket. Just as conditions were such that they managed to have a way of escape, getting out of the boom, out of the bucket before the bucket broke off. And that was fortunate for them, but it drove us to do some inspections, and we found a number of issues that were detectable before they became events, which is exactly how we're supposed to have it. Everything wears out, and everything has a certain amount of wear and tear that is going to be normal, that's acceptable. But if you're not doing the inspections, then you don't know what the level of wear and tear is until something fails. So that's an important concept. It's like the concept of a hook, a load hook. And if you look at OSHA, OSHA says, okay, if I have a hook and this is the shape of the hook, I'm allowed to have this much deformation in the hook before I have to take it out of service. If it's this much, then it's out of service. So wear and tear is okay and it's expected. But if we're not doing the inspection and we're not measuring or monitoring that wear, we don't know when to take it out of service. And we don't always do a very good job of that with our bucket trucks and our digger derrick trucks.
Yeah, absolutely. What would you say the role and responsibilities of the supervisors of the workers that operate those aerial platforms? What do they have in terms of responsibilities?
Well, we we have the brother's keeper thing, of course. Supervisor ultimate responsibility is to sign off on everything that we did because they monitor our safety activities. And they're supposed to ensure that everybody's reminded and we're ensure that each of these things takes place. We ought to be doing that anyway because we're the journeyman and we know what it is that we're supposed to do. The supervisor is supposed to make sure that that happens. But when it comes right down to the company itself and from the legal perspective of that supervisor with that crew, that supervisor represents the employer. Now, this is where the gray area is about when the employer becomes responsible for the conditions on the work site. Was the employer guilty of or negligent if the crew didn't do the job? Well, the employer sitting in the office of big city USA with a crew 200 miles away, working out of a service center, performing a task someplace, that employer can't see what's happening. He has an agent. The employer creates work standards, work practices, work rules, and safety rules, trains their supervisors and their employees on what each of these rules and practices and procedures are. And that supervisor is out there to ensure that the work takes place in accordance with the rules and to sign off and verify that the work did take place in those rules, following those rules. So the supervisor has a very important role when it comes down to the legal definition of the employer's responsibility with the crew and care for the crew. And a lot of supervisors don't realize that. It actually throws a lot of responsibility and some would even argue liability on that supervisor. But what we tell every one of them when we talk to them about supervisor responsibilities is, and a lot of them get surprised that level of responsibility could lead to a charge of negligence if they didn't do it. That's also the key to not being accused of negligence. You have everything you need at your fingertips to keep yourself from being accused of negligence, and that's the rules. We have practices, we have procedures, we have safety rule books, we have training. If we do those things the way the book says we're supposed to do it, then nobody has a claim against us. You can't be accused of being negligent. You simply do what the book says. And it's really that simple to do. But that also takes discipline. Now, that's the reason why we have we've coined a phrase. I guess if you call it coining a phrase at ISPC, when we teach, we talk about what's called rigor and discipline. And we emphasize that in every training session, rigor and discipline. The rigor is the rules that we operate under. That's the procedures, the policies, the safety rules, the training. That's the rigor. The rest of it is no other way but following those rules, and that's the discipline. So rigor and discipline has two very important roles. The biggest one is it prevents incidents in the workplace. If we follow the rules and do it the way the rules are. Now, if we do have some sort of incipient failure of a piece of equipment or something like that, the other part of the rules are to keep ourselves in the clear when things go wrong. But if I can say this was the rule, I did what I was supposed to do, then nobody can hold me liable for that. And I'm going to have a successful workday. So we say that there's accountability in every task, and the accountability can either be a party or a hanging. And if you've done what you're supposed to do, then it's a celebration. We did it right. We got it done. So if you don't do what you're supposed to do, then somebody's head's going to roll.
Yeah, and ultimately someone's life could be in the balance, right? So
that's exactly so.
What are the different aspects of a rescue from height?
We have a gray area here that has to do both with rescue and self-rescue. Now, OSHA has a standard in the fall protection standard that says that if I fall and I'm being suspended in my fall protection, that I must be rescued in an appropriate amount of time. That's not exactly how it says it, but the issue is that suspension trauma. If I'm in a full body harness and it's pulling up into my thighs, it cuts off the blood flow, creates suspension trauma, and you could be saved from the fall. You never hit the ground, but a few hours later, you could die from suspension trauma. So the rule is that if somebody falls into their harness, they have to be rescued. Well, it doesn't necessarily apply to a bucket truck. The larger issue probably is the actual mechanics of trying to accomplish that rescue. If I fall in a building construction, there's a whole bunch of people around. There's another floor right below. There's structure all around. There are people all around. It's pretty easy to be able to accomplish rescue. Same thing happens inside of a substation. But if I've got a bucket 170 feet up in the air and I only have one bucket, it's not very practical to say that I can go up and rescue that person that's hanging in their belt. So now the employer has to make a decision on how they would accomplish or what they would do in that case. So the very first thing to do is don't fall out of the bucket. Now that's pretty easy to accomplish if we do everything the way that we're supposed to be doing it. Now there are some, you could come up with all kinds of supposed scenarios where somebody would be bounced out of a bucket, and it happened a lot, in the 60s and 70s and 80s, and people got bounced out of buckets. Then we got more sophisticated in our training and operation and the quality of our equipment, and so that's very, very, very rare that happens anymore. The other thing that happens for a person to be out of a bucket is because of a failure of the equipment itself. But we discussed that earlier when we said inspection, looking for tolerances of mounting and equipment and wear and tear that will prevent the failure of the bucket of the platform. So the question that the employer, has to have, do I need to have a rescue protocol for people that are in a disabled bucket? And so that's where we come into self-rescue and rescue equipment. So there isn't anything in the standard that says that we have to do that. But because of the interest in doing so, there are a number of manufacturers that have come up with rescue equipment that is self-contained, small, compact, that we can put inside of a bucket and go with a person so they could essentially rappel down to the ground from the bucket. Or we have the kit that hangs on your body belt or your body harness that can be deployed, that you can stand in, that takes the stress off of your body harness to relieve the possibility of suspension trauma until rescue can get there. So the other side of that, rescue can get there. What does that mean? So does that mean there's another crew pull away that can bring their boom down, run over and get you? Is there a crew working in the neighborhood that can get you? Or is there a fire department that's 8 minutes away that can send a rescue out and do a high angle rescue and come and get you down? Or can you use the lower controls? So you have to think of all of these things. When we do bucket training, especially in live-line bare hand, one of the things that we do is self-rescue, and we do that using the tools that are available to the lineman. And this is as simple as using something like this 200-year-old figure eight that Rappel has used forever. Cost about $20-30. It's 8 inches long and 3 inches wide. It'll drop into any toolbox that you got. And with a little bit of training and practice, you can rig any rope to create a rappel device. And if you've got a guy on the ground, that figure eight works great because the guy on the ground becomes what's called bottom belay. Guy on the ground simply has to put a little fingertip pressure and that rope won't move through the figure eight. But on the equipment that we have, if we have a material handler boom, we've got a rope in there that will reach the ground from the material handler boom. If we've got a hand line, we've got a rope that will reach the ground. Or if we have a rescue bag that has 200 feet of 10 millimeter static rope, rolls up into a very small package with a clip on the end. I clip it to the bucket, throw it over the side, rig myself, and let myself down. And if you didn't want to use a figure eight, then you use what's called an ID, is the common name for it. And what it is a descent device that has an automatic braking system onto it that slips onto the rope, and then it's got attachment for a ring that attaches to your body harness. You jump out of the bucket, let yourself down. It's got a fail-safe design into it so that you don't have to worry about bottom belay, that if I squeeze the handle, it lets rope run through at a limited amount of time. And if I get confused or scared or afraid and I let go or squeeze too hard, it locks up and, to prevent you from falling, down the side. So the number one thing is to prevent the need for rescue at all or escape at all. And if we look at every one of the incidents that created a need for rescue or a need for escape, then we have to admit that every one of them was avoidable. And it was avoidable by simply doing inspections and testing and training, and it never would have happened. I only have a couple of cases and one of them was a case where a hydraulic leveling system broke loose of the mount, and the hydraulic leveling system caused the leveling operation to tilt the bucket over and had to shut down the bucket. And that's the only one that I've known of that was undetectable. It was a design flaw. And of course, you also could argue that it was the bouncing of the bucket that created the failure of the hydraulic leveling system, which is most all of them use the same thing. It's actually a silicon envelope filled full of silicon that has a weighted lever built into it. And when you tilt the boom, the lever moves through the silicone, creating the movement in the hydraulics that moves the bucket to keep it square. So the whole envelope broke off, laid over sideways, so the electronics thought that the boom was moving and kept trying to tilt the bucket. So that wasn't as detectable, but what we did realize was that all anybody has to do that's in this business is ride behind a bucket truck and watch the movement of the bucket as you're running down the road, especially if you're in right-of-ways, which brings us to another problem. We tend to leave 200 pounds of tools in the bucket, and now we've got that added weight slamming up and down on the bucket that's putting stress on the bucket mount. So now how well we bolt the boom down or clamp the boom down, what kind of support there is under the bucket, and what kind of wear and tear is being created simply by driving out to the job. So you've seen already that just in this short discussion, the number of things that can go wrong. And there's probably people that are going to be, thinking about this saying, man, we don't have any rules or any procedures or any, we just haven't thought about that. When stuff breaks, we fix it. And if you're lucky, it breaks when it doesn't affect anybody. But like I said before, what's your safety program built on? Is it built on procedures or is it built on luck? Because luck runs out.
Yeah, well, I didn't even think about, if you're driving down the road and you leave all your tools in that bucket, you're adding additional wear as you're driving up and down the road even that you're not accounting for. So you're not wearing, and if you're not searching for that wear, right? If you're not doing inspections prior, things could go wrong quick. I'd have to ask you, it sounds like the benefits of a competent person's guide training, do you think, what are those benefits, and do you think that there should be a standard?
Well, there is, and I'll say it this way, that there is a standard, but the standard is based on outcomes, on what we don't want to happen, and then understanding the path to the event. And that's what becomes a standard for training. If I'm driving down the road behind a bucket truck and I'm seeing the bucket bounce up and down, some people wouldn't think anything of that, where somebody else might say, that's bad. That could be doing some damage. And then somebody else might say, oh, no, that happens all the time. So, not everybody has the exact same perspective when they're looking at movement or something like that. So that's the reason why we have training to be able to identify problems and to be able to foresee those problems. Now, we can't see all of them, and I don't expect that to be able to happen, but what we talk about is big picture, narrow picture. All these things make a difference. And when we do our training, we do the same thing when we write our apprentice training programs. We try to cover things like development of technology, how things are built, and why things are built the way that they are. The rigor that goes into the mounting of a bucket has to do with what it takes to keep the bucket on the boom. And you have to try to think about what it is that they're trying to prevent. And movement of the boom creates the wear and tear on the basket. And if I magnify that by running down a right-of-way too fast and bouncing around, and I see my bucket bouncing up and down, it doesn't matter what kind of support you put under the bucket. It was designed to be there for a road trip. But if I drive across the bridge on a farm someplace or drive through a ditch, that boom is still flexible even when it's clamped down, and the bucket leaves the support and slams back down into the support. It's going to be doing damage, to the boom. So all of these issues are part of the training that we have to do for people to be able to understand how to protect their equipment in order to protect themselves. There isn't any particular criteria. Is sort of an evolution of understanding by the people who develop the training. But it's important that we train people to be able to see this bigger picture, to recognize how these things are interrelated. You and I were talking earlier today about the evolution of a couple of generations that don't think about or worry about how things are built. Maybe that's How It's Made. That's one of my favorite television shows.
Yeah, well,
How it's made. People don't even think about how these things are made, how this technology ends up in our toolbox. And when I say toolbox, I'm talking about things like bucket truck, digger derricks, cranes, and things like that. And we just make the assumption that it's always going to work the way that it's supposed to. And we need to have a much larger vision of what it is that we do and how we work and how these things work for us.
Yeah, absolutely. I mean, I think ultimately, the things that people can do that you talked about, doing initial inspections before doing the work, knowing how that equipment works and the operator manual, reading through that and understanding a little bit before you use that equipment will help mitigate, a lot of risk and a lot of, problems. And ultimately, the goal is to keep people safe, whether it's getting home to their family or keeping them out of harm's way on the job. I mean, doing that stuff can ultimately save your life. And I think that's what we're all here for. So I really appreciate you sharing that information with our audience. And, make sure, to check out Jim Vaughn's section, Train the Trainer, in IP Magazine. We are going to link Jim's LinkedIn and email address if you want to reach out to him. Again, he's at ISPC and he's a wealth of knowledge, so and he's always willing to share. So, Jim, we thank you. Or co-host the IPI Forum every month with David McPeak. Is that right?
Right, and Danny Rains and Jim. There's a couple of other people that participate. Danny and I are in almost all of them, but we've had more people as we've come in contact with them over the years. So there's usually 2 or 3 SMEs, hopefully subject matter experts with different areas of expertise. Danny and I, we cover a lot of area because we're old. We've been around a long time. And sometimes we make the joke. Yeah, we make the joke is that, if we haven't burned it down, it can be burned down. And we've learned a lot doing that. About won't do that again. But we've both been around for a real long time. And because of the kind of work that we do, we have a lot of exposure to a lot of different aspects of a lot of different topics. And so we are tickled to death that we're able to be on there along with some of these other SMEs that periodically invite, but everybody can sign in to this. Happens on the last Friday of the month. Like you said, David McPeak, you can go to the Incident Prevention's website and see when the next one is coming up. Doesn't cost you anything. And we call it Stump the Chumps. Sometimes we would love for somebody to ask us something that we don't know about, because that means that we have to go find an answer too. So sometimes there's information that we will have to do some research on, and everybody that is that logged in on that day is in a database, and they'll send a note out to them saying, hey, we learned this, we found out about this, or we'll answer it in the next session that's down there. But it doesn't happen too often, but it's a lot of fun. We enjoy being a part of it, and we're glad that IP and you guys have made it possible for us to do.
We appreciate all the knowledge and helping people get home safe at the end of the day. We'll make sure to include that link to the IPI forum. Like Jim said, it is a free registration. It's every month. David McPeak is the host, and you get a lot of really good peers on there asking questions, industry peers, talking about stuff that you may have the same question on. So make sure to join. And again, Jim, thank you very much for your time.
Yeah, and thank you, Nick.
The views, information, and opinions expressed during this podcast are solely those of the individuals involved and do not necessarily represent those of Utility Business Media and its employees. It is strongly recommended that you discuss any actions or policy changes with your company management prior to implementation.